Hi everyone, this is Mr. Siu from Math Accelerator. Welcome to P5 SA2 Mini Revision Lesson 5. Today we're going to cover the topic on angles and we will have questions on parallelogram, rhombus and trapezium. Okay, let's get to the first question. This is question 1 on parallelogram. In this diagram, ABFG and BCDE are parallelogram and BE is equals to EF. Part A, we need to find angle W, and part B, we need to find angle GFE. So let's see what we can underline. We have two parallelogram, and we were told that BE equals to EF. That means BE and EF. So we have, if these two lines are equal, that means we have an isosceles triangle, right? That's the first thing we notice. And the second thing is, if you need to find angle W, now angle W is inside a parallelogram, and we know that opposite angles in the parallelogram are equal. So we know that over here, this portion is equals to angle W as well. Now angle W and these three other angles will form a sum of 360. Okay, because of the property, angle at the point will give us 360 degrees. All right. So if we are able to find these two angles here, this one and this one, then we should be able to calculate the size of angle W. Okay, let's talk about the first one, which is CBE. Angle CBE. Angle CBE is also inside another parallelogram, and we can also make use of the property that opposite angles are equal to find out the size of this angle. If this side is 78, here will also be 78 degrees because they are opposite angles in a parallelogram. So we have one more angle to find, this angle. Earlier on, we identified these two equal lines, and we noticed that we have an isosceles triangle. So this angle and this, they are identical angle inside a isosceles triangle. So this angle that we need to find will be angle EBF. So angle EBF will be 180 minus 44, and we divide by 2. And we should be getting 68 degrees. So here is 68 degrees. So now we identified these two unknown angles, so we are ready to find angle W. So angle W will be 360 minus away 108 minus 78 minus 68. And we'll be getting 106 degrees. So that's how we calculate angle W. Next, we have to find angle GFE. Let's identify where is GFE. GFE is this big angle here. Let me mark out over here. Right, angle GFE consists of two angles. This one, which is angle BFG, and the other side, let me mark out in green. This side is angle BFE, right? So let's write over here that angle GFE is the sum of these two smaller angles. First angle is BFE, and the second angle is the first one is BFE, and the next one is BFG. Right, BFE is the one in green, and BFG is the one in blue. Okay, so how do we find these two angles? Okay, so remember we have an isosceles triangle. and these two angles are identical. So we already know that BFE is 68 degree, right? So that is easy. So BFE 68 degree. Next, we have to find BFG. BFG. So BFG, now we have to make use of this property that the adjacent angle inside a parallelogram always add up to give you 180, right? So let's do our calculation here. The angle BFG is the sum of angle W. Okay, so one moment. So I was saying that angle W plus angle BFG will give us 180 degree. So that's adjacent angle inside the parallelogram will add up to give you 180 degree. So next, we already know that angle W is 106. So now we're going to make use of this. We're going to take 180, subtract away 106 to find angle BFG. So angle BFG will be 180 minus 106. And that will give us 74 degree. So here, BFG 74 degree. So now we can combine these two together. So the sum of 68 and 74 will give us 142. Right, so that is our answer. So angle GFE. GFE is 142 degree. So this is making use of the property of the parallelogram to help us to solve this question. So please remember, the first thing we'll do is understand what are the properties of the parallelogram. Firstly, we make use of the property that opposite angles are equal to solve part A, and part B, we make use of the property of adjacent angles inside a parallelogram. Okay, we know that the two angles inside this triangle, which are adjacent to each other, will always give you 180. We also make use of the property of the isosceles triangle. We know that in an isosceles triangle, there are two equal sides and two equal angles. So we make use of this property two times, right? First time is to find angle EBF, and second time we identify that BFE is also 180 because this is an angle inside an isosceles triangle. And to find GFE, okay, we also understand that it is a combination of two angles. So we stated these two angles. The first angle is 68 and the second angle is 74. So we add them together, we get 142. Let's move on to the next question. In this question, we're going to talk about rhombus. In the figure below, ABCD is a rhombus. AE equals to CD and ADC equals to 68. Firstly, we need to find angle DAC, and next we need to find angle CAE. Let's highlight some of this information here. We have a rhombus. We have these two lines are equal, so we have to indicate where the lines that are equal. AE is parallel, is identical, of equal length to CD. Next, we have this angle ADC is 68. So in the rhombus consists of four equal sides. So if this side and this side they are equal, and this side and this side it is equal, this line is indicating B to C. All right. So the first angle we need to find is angle DAC. DAC is this angle over here, and we notice that this is part of a triangle, right? And this triangle has two equal sides. As mentioned earlier, this is an isosceles triangle. So this angle and this angle over here, they are the identical angle inside a triangle. So we can use the property to find angle DAC. The sum of angles in a triangle is 180, And if these two are identical, we can use 180 degree minus 68 and divide by 2. Then we should arrive at 56 degree. So the first answer, 56 degree for part A. Part B, we need to find angle CAE. CAE is this angle in blue. Alright, so in order to find this angle in blue, okay, let's see what do we have. We have this triangle here that I outline in blue. And this triangle is a smaller isosceles triangle, right? And in this smaller triangle, okay, the first thing we notice is we are able to identify this part. Because one of the properties of rhombus is opposite angles are equal. So if this part is 68, here will also be 68 degree, right? And since this is an isosceles triangle with these two equal sides, then we know that this angle is also 68 degree because they are identical angles in an isosceles triangle. Now, in order to find this angle CAE, we know that CAE combined with this angle, which is angle BAE, they are actually equals to 56. Because in a rhombus, if this side is 56, these two angles combined together will also give you 56 because they consist of two identical isosceles triangle. So let's find this angle first. This angle is angle BAE. So angle BAE, we will take 180 minus 68 minus another 68. And we will get 44 degree. So let's write here 44 degree. Next, we know that this 44 degree together with angle CAE will give us 56. So therefore, to find angle CAE, we simply take 56 minus 44 and we will get 12 degree. So that's how we work out angle CAE. So remember, we make use of the property of rhombus to solve this question. Firstly, opposite angles are equal. Secondly, we have 4 equal sides. And once we identify these 4 equal sides, we're able to tell that we have 2 identical isosceles triangle. And we make use of this property to solve part A to find angle DAC. Okay, we continue to use this property to understand that angle ABAC is also equals to 56 degree. Okay, we write over here. So angle BAC is also equals to 56 degree. And 56 and BAC is equals to the sum of these two angles, BAE and CAE. BAE we calculated to be 44. So 44 plus CAE will give us 56 as mentioned earlier. So we just subtract 44 from 56 and we will arrive at 12 degree. Let's move on to the third question. So in this question, we'll be on trapezium. EFGC is a trapezium that is with EF parallel to CG. ABCD is a square and CE equals to BE. Angle CEF is 90 degree. Find angle FGC and B, find angle CBE. So let's include some of the information from the question and see whether it's reflected in the figure below. So trapezium, all right, and then we have EF equals to CG. EF is over here, CG is over here. So we have This is the parallel lines. And EFGC is a trapezium. Next, we have a square. The square is ABCD. And next, we have CE equals to BE. CE equals to BE. Okay, so we have these two lines are equal. That means we have an isosceles triangle. And we have CEF equals to 90 degree. CEF. So here is 90 degree, right? So our first angle to find is angle FGC. FGC, this angle. Right, so here we know that this angle is 110. If this angle is 110, we know that between parallel lines, these two adjacent angles will add up to give you 180. So we can find this angle easily. So angle FGC, we will take 180 minus 110 degree, and we will get 70 degree. Next, we need to find CBE. Now CBE is this angle over here. So how do we find this angle? You know, this angle is inside a triangle. So if we can find these two angles here, then we will be able to solve it. So let's see what other examples, what other angles we have. We have this is a parallelogram. This is a trapezium. So we have this pair of parallel lines. If this portion is 90 degree, that means this portion is also equals to 90 degree. Right, this angle, this part is also 90 degree because the adjacent angle between the parallel lines will add up to give you 180. Next. So if this is 90 degree, then we can find this angle first, right? This angle. So let's calculate this angle. So this angle is angle ECD, right? How do we find angle ECD? So ECD together with 90 and 230, they form a sum of 360 angle at the point. So we calculate angle ECD. 360 minus 90 minus 230. And we arrive at 40 degree. So here is 40 degree. Next, BCD is a corner of a square, right? So it will be 90 degree. Let's write over here. Angle BCD is 90 degree. So next, I want to find this angle here. BCE, right? So we notice that BCE and 40 degree, they can add together to give you this angle BCD, right? So let's write over here and BCD. So here is equals to angle ECD plus angle BCE. We already know that ECD is equals to 40. So that's why a bracket here, this is 40 degree. So if this is 40 degree, then we can find angle BCE. So angle BCE will be 90 minus 40 degree, and we get 50. So we notice that this angle is 50 degree. Now, based on this information, CE equals to BE, we mentioned earlier that we have a isosceles triangle, right? And we have these two equal lines. So if this is 50 and this angle, they are identical angles inside a isosceles triangle. So therefore, we can find this angle already, right? So we know that this angle, which is CBE, is actually equals to angle BCE, because they are identical angles inside an isosceles triangle, and we found the answer, it is equals to 50 degree, right? So that is part B. Okay, so in this question, we make use of the property of trapezium, where trapezium has one pair of parallel lines, and we know that the adjacent angle, they add up to give you 180, right? These two angles are between parallel lines. If they add up to give you 180, we use this property to find angle FGC. Okay, next, we also use this property to find out that this angle is equals to 90 degree, ECG. Because we were told that CEF is 90, right? So this is 90, here must be 90, because both must add up to give you 180. Then we do further calculation to find this angle, right? ECD, right? ECD together with 90 and 230, they form 360, property of angle at the point. So we minus 90 and 230, we get 40. So once we have this, then the next one, we find ECB, right? So we calculated BCE. BCE 90 minus 40, we get 50. So after that, because of these two identical lines, okay, we identified that these two angles are identical angles in a triangle, and we use this property. Okay, since BCE is 50 and CBE equals to BCE, and we will get 50 as well. Right, so that's how we use the property of trapezium to calculate the angles in question 3. All right, so that's the end of our lesson. Okay, I hope you have a good revision with me as we recap all the properties of the rhombus, parallelogram, and trapezium. Right. Again, please remember to practice again these few questions before your exam. As usual, this will increase your confidence and improve your efficiency in solving this question should similar question comes out in your exam. All right. Thank you, everybody, and all the best to your exams.